Hello everyone and welcome to this new part of this project. And in this video I'm going to introduce this TF-IDF model and the Word2Vector model. And this part is actually can be regarded as the key part for this project because all of our analysis and the species and clustering are based on this step. So let me go into some of the details in the coding. So previously we have done the text cleaning for the text for the testing data set. Now we can conduct this TF-IDF step. And before that, because we have tokenized all these phrases and terms. If we want to do like more cleaning and if we want to conduct this TF-IDF model, we need to detokenize those words first. So in here, the first thing I do is I detokenize all these words. Okay, so with this code, it's gonna take you a while to see. So here I have done this detokenizing step. What I've done is basically I changed all these tokenized words. I converted them back to the data frame, and each column, each row is a document, and each column it's a word or a phrase. And for the last column, I just merged all these previous columns together to form a single column that contains all these words, and for this column, those are all detokenized words. I need to use that to do some more text cleaning and the TF-IDF. So now let's move on. Let's skip this more cleaning part first because this is the step that I added based on my TF-IDF results. So let's skip that and go directly to TF-IDF step. So with this step, I can with this code I can kind of rank. I can rank all those top, let's say, 500 TF-IDF weighted words. So highly weighted TF-IDF words, top 250. Let's see what those are. So it's gonna take you another like a few minutes because this data set is really big. Okay, so after running this step, this TF-IDF model returns me top 250 highly weighted words across all these articles. I can see that these are the words and the phrases. I can see that there are some words that I could be interested in. For example, like customer, like cost, service, market, design, this kind of thing, management, technology. This could be like potential criteria for the company location selection. But say words like say, new, also, need, well, use, these kind of words. Those are like commonly used words, across the articles. Those are the words that we often use to write articles. So actually those words means little to me because it cannot show anything on the company location criteria. So the next step is that we want to manually get rid of those words. So we want to manually delete them. Before we do that, we want to kind of test how this model works in detecting the phrases here. We can see that like the supply chain, which is a perfect detection for the phrases, and can see so for those ones that are not phrases, those are fine because it means to be not phrases because we are expecting that most of them are terms rather than phrases. But we can see like enlarge the image. Supply chain is what we have seen before. But this is the one that we didn't do more cleaning, but the one that we just rely solely on the TF-IDF. But now I want to remove those words that I don't want, which is this step, more cleaning step. So I want to run this. So we're gonna take another few minutes. So after several tries, I decided that this group of words are the ones that are not interested in. This group of words are also the ones that I'm not interested in. So after several try, I concluded that these are the words that I'm actually interested in. So I retained like 250 words that are the highly weighted words that are related to the company location selection. For example, like information, work plan, financial, software, like performance, fiscal, country, manufacturing. That's, these words, they could potentially tell some criteria of the company location selection. So I actually wanted to retain them. And for this next step, this next step is the step that that I just wanted to retain. These 250 words in each article, or I say like 200, maybe not 250, maybe just 200. So I just retain them in all the articles. And at the same time, I get rid of all the other words or phrases that are not in this in this word list. So, which is this step? Well, this step is going to take you a relatively long time because there are a lot of words and terms that are going to be get rid of. So the running time is actually takes longer than expected. But let's run it. So after we run this step, we get rid of all this all the words that are not in this 200 word list. We will have a cleaner data frame, and in which each row represents an article. So it looks like this. So if we want to just print the first like 100 characters, I can just use let's see. Hold on 1 second. Yes. This is gonna. No, it's not like this. Which is column width. Yes, it's column width. So we'll see that that this DF phrases, which is the data frame that we're interested in analyzing later, is actually cleaner. And in this this one, we'll see that it only contains the 200 words in each document that we're most interested in. So you will see that sometimes you see people, it's following after people because we get rid of all those unrelated words in between them, and like manager, employee, international, country. Like another employee. So you see that it cannot actually form a sentence, but these are just words. These are just words. But we'll emphasize that the order of these words that are not changed. So the distance of each words are still not changed. So for example, the people comes after this people, and the manager comes after this people. So the order are not changed. But but the distance we cannot say is not changed. It changed a little bit, but it kind of shortened. But But you know, all these words, all these distances between these words has been shortened, so we can kind of neglect that aspect. Okay, and with this data frame, we can go on to the word embeddings step. For this word embeddings, which is the Word2Vectors, I also wanted to use the Genism package, in which I use this corpora, modules, and similarity. I use this step, which is the same step I did previously, in tokenizing and changing the untokenized data frame to a tokenized frame. So this step I changed it to a corpus first, and then I changed the corpus to tokenized data frames, and then I do the Word2Vector. Okay, let's run it. Okay, now we have trained a model called, which is just called the model. So one of the good things for text embedding or Word2Vector is that it can help you to find the most similar words related to a keyword that you are interested in. For example, here, if I'm interested in the word text, I can find out some related words that is related to text. So let's see what are those words are. So we can see that it returns as some words that are most closely related to articles. I just selected the top 10 words like income, profit, loss, liability, fiscal, incentive, period, revenue, asset, and state. So it kind of makes sense. So it makes sense that these words are related to the word text. So now I have this word embeddings model in here. The next step is the PCA. The PCA part I'm going to introduce you in the next video, so I hope you could keep watching. Thank you.